in this example, we need to find the volume of the solid obtained when we rotate the region that's bounded by the given curves about the line y equals 2. There's our axis. And the two curves that we are going to find the region bounded by is y equals x squared and y equals 1. So when I look at, here's my y-axis, here's my x-axis. So I have the parabola x squared. Then I have the line y equals 1. And so this area here that I'm shading is the area that's bounded by those two curves, and that's what we're going to spin. And we're told to spin it around this axis of y equals 2. So when I spin this, this whole region here is going to come up and go around the line y equals 2. So if you notice, what's going to happen is there's going to be a gap or a cavity in this solid because of the space between y equals 1 and y equals 2. So because there's going to be a cavity, we're going to use what's called the washer method. And the washer method says we integrate on the interval of interest. Well, in this case, we'll talk about it generically a to b. And then you multiply that integral by pi, and then you take the outer radius, I'll call that radius 1, you square it, and you subtract radius 2, the inner radius, and square it. That's what you're going to integrate. So what we need to do is imagine that we're taking a cross section of the solid. So when I imagine that I take a cross section of this solid, I have the cavity in the middle because of that empty space between y equals 1 and y equals 2. So the radius of that space is going to be 1, because if I imagine that I'm making a cross section, that radius is going to come out this way, a distance of 1. And that is the distance between 1 and 2, that gap. Okay, now the radius of the outer ring, so let's look at from here to here, that distance is going to be whatever the difference is between 1 and x squared. That's this difference right here. I'll highlight it in yellow. That radius, so if I take 1, which is the top curve, and I subtract the bottom curve, that's 1 minus x squared, but then we have to add on this distance here. So we have to add on another 1 because of that gap, right? So from here to here, that's going to be 1 minus x squared, but then we have to add another 1 for that gap. So the second radius that I call radius 2, that outer radius, is going to be 1 minus x squared plus another unit for that gap. So when I simplify this, I'm going to get 2 minus x squared. So this radius from here to here is 2 minus x squared, and then this radius, the inner radius, is just 1. So now if I got to figure out what interval that's on, I'm looking at where the regions cross, or I'm looking to see where the intersection points are of these two curves, and it intersects at 1 and -1. So I'm going to integrate this from -1 to 1. I have my pi out here. I'm going to take my outer radius. Whoops, I labeled this wrong. This should be 1. This should be radius 2. So I'm going to take my outer radius which is 2 minus x squared, and square it. And then I'm going to subtract my inner radius, which is 1, and square it. And then I'm going to integrate this. When we integrate this, you should get 11.728612573402, and then just follow the directions on how you're supposed to round.